All right, I am Frank Visaggio. I'm going to be talking about ECMAScript 2024. And the reason that it's sometimes called ES15 is because it's the 15th edition of the standard, but if you search that, sometimes you'll get the 2015 version, so they typically drop the former, if you will. A little bit about me. I'm an engineering manager for CCRI. We do real-time analytics and spatial analysis of events on maps. We're hiring in Northern Virginia and Charlottesville, so if you're interested, talk to me, send me a message, etc. And two thanks today. My wife and child can't, I owe their success or my success or being able to present here due to their support, and then also my coworkers who traveled from all over the US to be here, and then the ones who couldn't be here, they make me better every single day, and I'm really thankful for that. So let's start off with ECMAScript 2024, right? Why on earth is it called ECMAScript, not JavaScript? Well, fun fact, Oracle has that name trademarked, and they got that from Sun, so that's why it's under this name. It used to be an acronym. Now it's just from ECMA International, so the acronym's no longer, but that's the standards organization. And some standards that they maintain, in addition to the JavaScript standard 262, is C# language specification, JSON, in addition to a whole bunch of other standards. So why on earth do you even need a standards organization? Part of that is the consistency across environments, making the web more predictable and reliable. Interoperability. I know I hate bugs where it just doesn't work in one version of a browser, so ideally having apps work the same regardless of the browser. And then there's also a benefit of industry collaboration from the implementers, the browser vendors, different devs, other stakeholders, makes the language more robust and well-rounded. That way there's only, ideally one set of documentation on how core features work in it, if you will. So next, it helps to know what TC39 is, the Technical Committee 39. So they develop and maintain the ECMAScript language specification. Whole goal is pretty much trying not to break the web while making a more pleasant developer experience. So different members are on that from the different, browser vendors, et cetera. They typically have annual releases, if you will. And it's a very open process. You can see their meeting notes on GitHub, all the different proposals and the different stages, and you can contribute, and it's very open. Now, anyone can submit feedback, however, it's most impactful on a proposal before stage 2.7 because the API, the spec isn't as locked down, so if you want to say hey, look, maybe have you considered this, change things, doing something that's earlier in its infancy, there's more time to change it and your thoughts are there, so that's just a screenshot of their GitHub page with the different issues. So to understand the different stages, proposals start at stage 0. You can make one right now. There's no entrance criteria, and it's really just making a case for an improvement, identifying potential challenges, if you will. Then you jump to stage 1, which there needs to be a champion or champions to bring that proposal and to champion it, and then it'll transfer over to the committee, and it's owned by the committee, and then you'll have a public repo on GitHub as well for the contents of that repo as it evolves. And the whole goal of stage 1 is sort of designing the solution, making a case and seeing what other libraries do and other languages when considering solutions, if you will. After that, stage 2 is the draft. So really the whole goal there is refining the solution. You'll have a more concrete solution chosen by the committee. The design's still in draft, so it's, while it's likely to be somewhat standardized, it could change. There's unknown factors that could change the APIs, et cetera, but still a great time for discussions, contributions, et cetera. And you'll have different examples of the usage and an initial spec of sort of what the APIs, the syntax looks like. One key thing to bring to light here is if you see something in stage 2, there might be experimental implementations to get feedback, different sandboxes, no matter, even if a very reputable company made it or a reputable body, typically they're not for production. So you can play around with it, give it feedback, don't use that in production, if you will. And then 2.7 is a newer stage, if you will. That's candidate, and pretty much what they found is it's hard to write the implementation just from a spec sheet. Sort of having the output of the different tests is very helpful. So testing and validation is huge here in 2.7. So to get to 2.7, you'll have like a complete spec of the syntax, and then the reviewers will sort of approve that spec. However, it's pretty ironed down. It's not going to change a ton once it gets to 2.7, unless that feedback's coming from different tests or prototype implementations and actual usage. So really the test and the test suite, which is also on GitHub, drives sort of the changing at this point in time, if you will. Then stage 3 is when things get recommended for implementation. You're going to see this yellow bar, my apologies if you're colorblind, at the top, but like certain things are experimental. When they say that, trust them. Don't use it in production. You can interact with it, etc. But like, once something is at stage 3, it's been recommended for implementation. They're not expecting many changes. However, sometimes there will be late changes if when they're implementing it in the different JavaScript engines, there's incompatibilities, certain production issues, certain performance issues, et cetera. So they're really trying to get sufficient testing and implementation experience regarding, once it's out into the web and in the hands of a larger audience, if you will. And then stage 4 is my favorite, ship it, it's finished. So once it's in stage 4, it's proposed, it's ready to be included in the spec. What's it take to get here? At least two compatible implementations need to pass all of the test 262 acceptance tests. Very robust test suite, if you will. You could see them all on GitHub. And they'll collect a wealth of the real-world usage to understand that, and then the proper pull requests, et cetera. It's considered stable. Now, one thing that I want to mention is once it's here, it's considered stable. You could start using it even if it's not earmarked for that year. So at a certain point in time, which I'll discuss in my next slide, they may have to put it in the next year's standard. So take a look at this chart, right? If you notice duplicate name capture groups. Well, why on earth it was approved in April 2024, but it's not going into 2025? It's because typically they decide the new features January, February. It gets approved in June, July. There just wasn't enough window there, but that is still ready to go. It's in stage 4. And and then all of the proposals, the status of where they are. I can't cover every proposal here because I have only 30 minutes. You could see them all on their GitHub repo. So now let's talk about some changes. In JavaScript, strings are UTF-16 encoded, which requires surrogate pairs. So there's 2 new methods now, is well-formed and to well-formed. And pretty much the way that you would use this is like, let's say you have in line 2, you have something that has lone surrogates. You can see with that in line 4, you could just call the is well-formed and it'll give you true or false on whether or not that is a well-formed, if you will. Now, if we look at line 8, that has the 2 surrogate pairs as one would expect for the rocket emoji. And if you say, okay, is that well-formed, that would return true. Now, certain things, like whether you're interacting with different APIs, interfaces, need things to be well-formed. So for example, encode URI, that needs to have well-formed, it needs to be well-formed, otherwise it's going to throw an error. So what you can do is if you had single lone surrogate pairs, like in line 2, and you went to send that there, that would typically error. But what you can do is you now can call to well-formed, and that will add the proper Unicode replacement character next to both of those in order to allow it to work. So I'm going to show 2 examples of this. If you're not familiar, can I use is great to see like these different stage 4 proposals. Notice a lot of users on the web have access to this. It's in a lot of browsers, but it's always good to see sort of who finished implementing different things in stage 4. And a prime example is even though atomics.waitAsync is in stage 4, notice Firefox didn't get a chance to do it. So that's why it's good testing and sort of seeing who rolled it out. And they have reasons for not rolling it out yet. But depending on where your audience, your users are, it's always worth seeing that to be aware of it. So just because it's in stage 4 doesn't mean it's available everywhere necessarily. So the waitAsync, it's a static method, and it pretty much allows us to wait asynchronously on shared memory in a location and returns a promise. And unlike atomics.wait, it's non-blocking, it's usable on the main thread, if you will. So just as a refresher, if you're not familiar, atomics, set of static methods that will help synchronize operations between multiple threads. And I think of an atomic operation as like a single unit of work that can't really be split up, if you will. And this is really useful for sort of having different worker synchronizations when they need to do something somewhere else, but you don't want to block the main thread. You still want to have interactivity. And then there's an additional stage 4 proposal, shared array buffers. You can now resize them. So that's good for memory and performance, because before you would either have to over allocate and make sure that whatever you're putting in there doesn't go over, and then if you under allocated, you would then have to copy it and then over allocate the next time. So that's pretty neat that those are able to be resized. So just an example for waitAsync, if we take a look at this, we'll have a shared array buffer on line 1. Then we will have the array to view that buffer, and then we're going to initialize the first element to 0. So what we're going to do is every 2 seconds, if you see the set timeout on line 21, every 2 seconds we're going to change that value. And the meat of this is in line 13. So that atomics.waitAsync, you have the typed array, which is the shared buffer. You have the index, the position that you're going to wait on, and then you have the value that you're expected to test. Now, this is also an overloaded function. You could add an optional timeout there, but I did not. And pretty much what that's going to return is the .async property. It'll return a Boolean on whether or not it's a promise. And then value, if async's true, which it is in this scenario, that will return a string of the fulfilled promise, and it'll either be OK or timed out. So here it would be OK, but notice I am doing this every 2 seconds. So if I just put a comma on line 14 and said, okay, I want it to time out after 1.5 seconds or 1500, well, then it would return timeout, if you will. Another thing that made it to stage 4 that's in this version of the standard is object grouping. So you can group elements of an iterable according to the string values returned from a callback function. And there's 2 things to take note of here. It won't modify the original object, so it's non-destructive. And you might be thinking, well, I use Lodash for this. Why do I care? Well, that's great. You still can use Lodash. It's not going to break anything that uses Lodash. This just might be possibly a preferred way to do this without breaking the web, if you will. So if we have a list of or an array of different artists, and let's say Taylor Swift, her ticket prices are a little bit more than Utah's own Post Malone. We see that in the callback function. We might sort and say, okay, anything that's over 150, that's probably a sold out show. Otherwise, the other ones are a value. So if we call the object.groupBy, we send it these artists with that callback function, you would get an object that looks like the following, with sold out there, with the ones that fall into that category, and then the ones that might be deemed a value, if you will. There's something very similar to this, which is map.groupBy. And that's pretty much the same thing, except you're grouping elements into a map object or like key value pair. So once again, I've got an iterable of ski resorts. If you didn't know, 2 of Utah's ski resorts are skiers only or no snowboarding allowed. So that's why I put the snowboarding allowed as false for some of those. So then if we sort of have the concept of no snowboarding and snowboarding, and then if we do a map.groupBy in line 10 and we give it ski resorts, we can then say, okay, well, based on the value of snowboarding allowed, the keys will either be there's snowboarding or there's no snowboarding. So then when we take that result object or that result map and we sort of look at the different keys, no snowboarding or snowboarding, you would then see the different results. So it's pretty much the same thing, but it'll put it into a map object. This is another one that's in stage 4, and this one, I don't know, people might say it's mostly syntactic sugar because there's other ways to do this before this was added, but it could be neat when you're interacting with non-promise-based APIs. So if we look at promise.withResolvers on line 5, pretty much what you're able to do is you're able to get the promise and then the resolve and reject functions separately. So that's going to allow you to control when to resolve or reject the promise outside of the executor function. So in this example, I've got every second, half the time it'll successfully resolve, the other half it'll reject. And you can see that you can use those in lines 10 and 12. And then just like any other promise, you could then handle when it resolves or handle or catch the error states, if you will. This one, I'm really looking forward to this. Mind you, there's a reason that I put that up there. There's a reason they put this up on the repo. It's still experimental. So like even though there's polyfills, even though you don't want to use date, even though you want to rip moment out of your code, if that's the scenario you fall into, use discretion. It's, wait until this makes it to stage 4 would be my suggestion. But there's a reason they put a warning on it. So full disclosure there. But there's a lot of reasons why date in JavaScript is possibly suboptimal. The fact that like your dates, your times, and your time zones are together. And there's like, we could have an hour talk just on gotchas with that. Like for example, if you have an app, you go from one time zone to another while using it, and there's certain cities on the border of 2 time zones. And browsers put a lot of work into trying to mitigate that to the best of their ability. So this might be a more straightforward and easy way to handle concepts of dates, times, time zones, et cetera. And you don't have to sort of think about all of that depending on what your use case is. So you could have just, plain dates in line 1. You can add X amount of days to it. You can have just a plain time. You don't need to worry about the date. You don't need to worry about the time zone, et cetera. You can, have a date time as we do in line 6. You can work with duration. So like X number of hours, minutes, et cetera. And then you can add a duration to a time as we do in line 10. You can compare different dates. So if you have, plain dates, you sort of do temporal.plainDate.compare, and then you'll be able to do that comparison, if you will. You can also, all right, so temporal.now is the time like right now. So if you do that based on your date time ISO, let's say that we're in London, if you will, you'd get something like you see on line 18, and then you can convert it, right? So you would take that time, and then you would say, okay, with time zone, and then switch it to maybe New York if you wanted to switch it to the East Coast, if you will. You can also calculate the difference between 2 dates and sort of see, when did I start, when did I end? And if you're not familiar, okay, like P366D, I'm not a time expert, but like the ISO standard, you can read up on 8601. P is period, so 366 days. Remember, 2024 is a leap year, so that's something to keep note of. And then I think one of the most impactful things is just the formatting of times. So there's a lot of opportunities in regards to your date style, your time style, things of that nature when displaying times, which should have a lot. Now, mind you, this is not everything in the temporal API, but it's pretty much locked down because it's in stage 3. So check out the GitHub repo, look at all the scenarios that you can use it for, because it's pretty impactful in my opinion, I guess. And then lastly, something that I wanted to also cover is the new set methods. So this is in stage 4. I put an asterisk here because even though it is in stage 4, it's not going to be added to the standard until ES 2025, but you still can use it now, et cetera. And just as a reminder, so like if you have a set, and let's say I have an array of 1, 4, 23, every element needs to be unique, so I can't add 23 again. And I just wanted to give a shout out, so I didn't want to have to generate those images myself for the set explanation of the different methods that they have, but Mozilla does a great job of that. Their contributors and their dev docs, so like if you're ever looking, how to reference these dev docs, like maybe the GitHub repo isn't as explicit as you would want, that might be another resource to further clarify, if you will. So some of the things that they added was the difference between 2 sets. So like what's different, the intersection, where's the overlap? The opposite of that would be the symmetric difference. And then also the union, sort of the entire inclusion. And then some of the different Boolean methods that you'll have is between 2 different sets is A disjoint from B, or none of the values are in the other one, if you will, or is A a subset, so all of the values from A are in B, or the opposite. A is a superset of B, so all of B's values are in A. So that's some of the things that you can look forward to in ES 2024. Thank you a ton for your time. Appreciate everybody being here. Thank you.